Hi everyone! In this video, we're going to show a sample problem for improper partial fractions under the topic Integration by Partial Fractions. This is the sample problem. Evaluate the integral of this rational function 2x cubed minus 4x squared minus x minus 3 all over x squared minus 2x minus 3 dx. Let us copy this problem down here. Take note that the degree of numerator is more than degree of denominator. Thus, this is an improper fraction. In this case, the first step is to divide the numerator by denominator. It means the numerator is the dividend, the denominator is the divisor. When we divide, we will get 2x. Then 2x multiplied by each term of the divisor, we will get 2x cubed minus 4x squared minus 6x. We subtract the dividend by this polynomial down here. The final answer is 5x minus 3. It means 2x is the quotient. We have the remainder 5x minus 3, and the divisor is the x squared minus 2x minus 3. So the answer can be expressed as 2x plus 5x minus 3 all over x squared minus 2x minus 3. This fraction here is equal to this expression. It means our integral can be expressed as the quotient here. So we have the integral of 2x dx plus the integral of 5x minus 3 all over x squared minus 2x minus 3 dx. Now let us solve this integral here by partial fraction. Let us copy this fraction in here. At first, let us try to factor out the denominator. And the factors are x minus 3 times x plus 1. Note that the factors of denominator are non-repeated linear factors. So by partial fraction principle, this is equivalent to a all over the first factor x minus 3 plus b all over the second factor x plus 1. It means this integral here can be expressed as integrals of partial fractions. And we can rewrite these integrals to be 2 the integral of x dx plus the integral of a over x minus 3 dx plus the integral of b over x plus 1 dx. Now let us solve for a and b. Let us multiply this equation by the LCD. Take note that our LCD is the denominator of the left-hand side. By doing so, the resulting equation will be 5x minus 3 equals a times the quantity x plus 1 plus b times the quantity x minus 3. This is now our working equation. First, let us solve for a. It means we will try to eliminate b. Let us think of a value of x so that b would be eliminated. We let x to be equal to 3. Substituting 3, we have now 5x minus 3 becomes 5 times 3 minus 3 on the left side equals a times x plus 1 becomes 3 plus 1 plus b times x minus 3 becomes 3 minus 3. Now look at this part. The 3 minus 3 will give 0, and the 0 multiplied by b becomes 0. Simplifying now this equation, the left side becomes 12 equals 4a. Solving for a, let us divide this equation by the coefficient of a, which is 4. So the value of a equals 3. Let us now solve for b. Looking at our working equation, let us think of a value of x that would eliminate a. So we let x to be negative 1. Substituting negative 1 to the x, we will have 5 times negative 1 minus 3 equals a times negative 1 plus 1 plus b times negative 1 minus 3. This negative 1 plus 1 will be 0, and 0 times a will be 0. Simplifying now this equation, the left side becomes negative 8 equals, the right side is negative 4b. Simplifying further, the value of b equals positive 2. Now we can substitute the values of a and b respectively to the integrals here. There we go. Now, since the values of a and b are constants, we can move the constants outside the integral sign. So it will be like this. Now let us do integration of these three integrals. In the first integral, we're going to apply the power rule of integration. In the second integral and the third integral, we will use substitution method, that later on, the answer will be a natural log. So for the first integral, it will be 2 times x squared over 2 plus this 3, we copy down here, the integral of 1 over x minus 3 dx will be natural log of absolute value of x minus 3 plus the constant 2 we will copy here, and the integral is natural log of the absolute value of x plus 1. We can simplify the first expression that we can cancel 2 and the denominator 2 down here. Writing now the final answer, we will have x squared plus 3 ln of absolute value of x minus 3 plus the constant 2 ln of absolute value of x plus 1, then plus c. This is now the final answer. I hope you learned something from this video. See you again next time.